Ooh, hello. Finally got my stream open. uh, just hang out here until 7. Feels good to be on time. Doom, doom. Hello, if you just showed up, I am just being quiet because I'm waiting till 7. So we can wait for a few more people to get in here before I start cranking out some math. If you're curious about the itinerary, I guess today I have the review here. I have this document where I snagged a free response question that's fairly similar to the style that we're going to have. And then I took all the questions that had a lot of misses on the online U-Sub homework and threw those together. So those are my main pieces. I should have grabbed the U-Sub paper homework because there were some on there that maybe would have been worth going over, but I didn't do that. Otherwise, I also have the quiz. If there are any questions about the type of question, the quiz question that's going to be on the final, which is the average value sort of problem, but we should end up hitting that at other points in here. And then the notes themselves, which have the type of question shown, which is, these are 2 examples of. Whoops, derivative graph. No, that's the right one. Cool. Yeah, FRQ3 is the style for this one. All right, we have some opening questions from Emma. Can we do chapter 4, 3, and 5 on the review? Sure. Chapter 4, 3, and 5. Okay, yeah, 3 is a pretty good question, so that's a nice one to start on. So in 3, you're given a derivative equation, and it says what's the average rate of change of y with respect to x on the interval 1 to 4. In order to find that, we have to actually find the equation of y, which in this case is going to involve doing an antiderivative here, and technically moving this dx to the other side. If we integrate x, we get x squared over 2. If we integrate dy, we just get y, and we get a plus c. And so this is our actual y equation, which was just the antiderivative of the derivative equation. And then all you had to do was do y2 minus y1 over x2 minus x1. So like y with 4 plugged in minus y with 1 plugged in. So if I plug 4 into this, I get 8 plus c. And if I plug 1 in, I get 1/2 plus c. All over what x2 minus x1, which is just 4 minus 1. You might notice the plus c's cancel out, so you didn't even really need that piece. And you just get 7.5 over 3, which is 2.5, and is the answer to that one. So that's one where average rate of change actually required us to do calculus, because we had to actually find the y equation. The actual rate of change at halfway in between these, 2.5, would also be 2.5 because our original derivative equation, we just plug in the x value, 2.5, and we'd get 2.5 for the actual slope. So this one actually matches on both ends there. Let's go to Emma's second question, which was 5. What is the average value of y for the curve? Okay, yeah, first quadrant question. So in order to do this question, you have to know what the graph looks like. And to do that, you factor out an x, and you get the two zeros of this function are 0 and 3 from those two spots respectively. It's an upside down parabola, which means it looks something like this. And once you've drawn this picture, what's in the first quadrant is just this stuff, which goes from 0 to 3. So pretty easy to set up our integral. We're integrating from 0 to 3. We have our function, and we're dividing by 3, which is the width of the interval, to find average value. So we take an antiderivative. Whoops, I should have put a dx here. 3x squared over 2 minus x cubed over 3 all over 3, and I'm plugging in 0 and 3. This isn't too bad to plug in because 0 just gives us 0, so we just get 27 over 2 minus 27 over 3 over 3. So some cheaty shortcuts. This is just 13.5 minus 9 over 3, which is 4.5 over 3, which is 1.5 or 3/2, which is an equivalent fraction. Yeah, that's that one. So both of those had a wrinkle in them. 5 required you to draw a picture to know what your bounds were or how to even set up the problem. And 3 required you to realize that you had to take an antiderivative to find the correct or pertinent equation. Let's see. What's up? I went over one of Chinmai's questions, so we'll go to the other ones. Apparently chapter 4 was the brutal chapter here. That's our most recent one. Wow. Okay, as far as question 4 goes, the easiest way to do question 4 is to graph it. So I guess 4 and 5 have something in common. Because if you know what x minus 3 looks like, you know it bounces off the axis at 3, because if you plug 3 in, you get 0 in here. We're integrating from -1 to 6, which means that's where we're integrating. From 1 to 3, rather, is too long, and the slope of this thing is 1, or -1 for the first part, 1 for the second part. So we just go over 2 up 2, and that makes the area of that rectangle, or sorry, triangle 2, 1/2, 2 times 2. The other triangle goes from 3 to 6, so it's 3 long and 3 tall. 1/2, 3 times 3 is 4.5. And the two areas add together to give you 6.5, or 13 over 2. Now, this is the easy way to do this with no calculus. There is another way to do this with calculus, if you're so inclined to do so. And that way is to split this up into two integrals, one from not 0, but rather from 1 to 3 of our original function except multiplied by a negative sign, so -x plus 3. Because that's the negative slope part, the first part from 1 to 3. And then add to it the integral from 3 to 6 of x minus 3 dx. And this would give you the exact same answer. It just would take a minute longer because you have to do all the integrals and stuff. But yeah, that's choices. 6. Wait. Chapter 4, 4, 5, and 6. Oh, 6 is the added question that I didn't put in this document. Oopsies. I know what it was like. So maybe it's worth it to just go look at one of those since I didn't put it in here. So I'm just going to do a similar question because I forgot to upload the document that had question 6 in it. It has our limit definition of the integral questions. So, little review of this. This means integral sign. Then usually they give you some other mess, or I give you some other mess of stuff that goes inside our sum. In the case of the question I'm going to write, I'm going to do something like 2 plus, what should I do? 10i over n times 5i over n, and let's raise that to the 7th. Maybe that's a similar question to the one there. I don't know. Do I want to do this, or is this too evil? Let's back up the difficulty. This is more realistic to what would be on the final. Alright, so if we're making this integral now, we should immediately know that this stuff is our dx here on the edge, which does tell us that our, did I mess up? Yeah, this doesn't have an I here. Oopsie daisy. Alright, anyways, that stuff right there is our dx, our 5 is our width. But we also know this other thing, which is that our starting value is 2. Oops, I wrote width off the page. Our starting value is 2, so our integral is actually the integral from 2 to 7. This entire piece is our x if I include this in my bounds. I'm going to write the other version of this in just a second. Which means this is just the integral of x to the 7th, which means I could scoot this dx over here, and booyah, I have an easy integral. And on the actual final, I probably am inclined to not have a multiple choice where I write out a whole bunch of these garbage things, and instead would ask you to solve this at this point. So if you did that, you'd integrate to x to the 8th over 8 from 2 to 7, and so the answer would be 7 to the 8th over 8 minus 2 to the 8th over 8. Wow. And then I could put this, whatever this number is, as a multiple choice answer. So, okay, the other version of this is you could just say this is x, and if you do that, your integral is just the integral from 0 to 5 of 2 plus x to the 7th dx. And these have exactly the same answer. Now, I said that a lot in class, but just to demo real quick, if I integrate 2 plus x to the 7th, I get 2 plus x to the 8th over 8. We're plugging in 0 and 5, and lo and behold, when I plug in 0 and 5, I get 7 to the 8th over 8 minus 2 to the 8th over 8. So this is why these are exactly the same, and why they're both acceptable integrals that are equivalent to the original thing that I made. All right. Can't decide if Nick's memeing or not. Oh, I guess Nick wrote the question that I was looking for. So okay, I'll solve that one too. Now that I solved another one. So it's your limit of all that garbage. It's got a 4 over n, and it's got a 3 plus 4i over n. Yeah, okay. The easiest way to do this is to just say it's an integral from 3 to 7, because our width is 4, and we're starting at 3, of x dx. And that would be a very reasonable test question to ask, because then you integrate it, and you get x squared over 2, evaluated at 3 and 7, and you just get 49 over 2 minus 9 over 2, which is 40 over 2, which is 20. So if that is actually the question, That's a pretty nice question, and that's a good idea for actually a type of test question. One that boils down to a pretty nice answer, like this question I put on the review is. At least, maybe. All right. So, Chimai, I didn't bring or I didn't drop the U-Sub worksheet on my tablet, and I only have one USB port. So if you could write roughly what the question looks like, I can probably solve it. But that question 17, I'm going to struggle with. FRQ questions, I'm going to save for a minute. So I'm going to go to Aspen's question, which is chapter 2, 3, and 4. So we're moving out of integral land for a minute. Yep, chapter 2. Okay, the normal question. You have to be able to take a derivative here because that's how we find slope. So if we take a derivative, we have to do a little bit of product rule. So a prime b looks like that, and a times b prime, I gotta then chain rule out of pi here. If we now plug in 1, sine of pi is 0, so that's cool. X is 1, cosine of pi is -1, and we got this pi dude here, which makes the slope negative pi. And then if I make it normal, that means perpendicular to a curve. That's what the word normal means, so perpendicular to a tangent line to a curve, kind of. And so all we do is take the slope and perpendicularize it, which is 1 over pi. Yep. Yay, Liam Minecraft is here with the spammers. Alright. 4 was the other one, I believe. Yeah. Okay. So, in 4, you're given an x value. It asks you the rate at which sine squared of x is increasing. So, right away, when I see rate at which sine squared x is increasing, I know I got to take the derivative of sine squared x. So that is 2 sine x cosine x. Remember, it's not cosine squared x because you actually have to remember to do the chain rule here. And sine squared x is the same thing as sine of x squared. You do 2 times the inside times the derivative of the inside, which is 2 sine x cosine x. And then all you do here is, usually when there's an is in one of these questions, there's an equal sign there. And then all you do is k times the rate at which x is increasing. The rate at which x is increasing is the derivative of x, which is 1. So this side is k times 1. And then all you do is plug in pi over 4. So it's 2 times sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2 equals k. So k is 1. 2 times 1/2, which is what root 2 over 2 times root 2 over 2 is. Oh, yeah. Do I have band power on these people? Yes, I do. No, I don't. Rats. I have to go into the actual client on this computer. Poopy. Well, just gotta scroll up to see what's up now. Okay. We got Nick and Chinmay actually gave me a question here, so I'm gonna go to my sketch pad, and it looks like lower bound 0, upper bound 1, x over x plus 1 to the 1/2 dx. And I assume it has a square root on there. But this is a good rewrite. And so the sad panda part of the start here is that you can't actually do x divided by these things inside the 1/2 power individually. So this is the kind of U-substitution question where you do use substitution, and we do it on the most complicated thing always. But it's not actually undoing the chain rule here. It's just a way of allowing us to actually divide by something in a square root. And so if we make our U substitution, U equals x plus 1, subtract 1 from both sides, I get U minus 1 equals x. And I guess I should have taken the derivative. Very easy derivative here. Du equals dx, or du over dx equals 1. Now, if I rewrite the question, it's clean. It's the integral from 0 to 1 of, at the top is u minus 1 instead of x. The bottom is u to the 1/2. And dx is du. So entirely rewritten in terms of u's. But what this has bought us is we actually can divide now. U divided by u to the 1/2 is u to the 1/2. And I just realized I did a major faux pas. These bounds are garbage. I need to convert my bounds. So if I plug 0 into my new u equation here, I get 1 as my new bottom bound. And if I plug 1 into this equation, I get 2 as my top bound. So now that my bounds are fixed, I can simplify this. U divided by u to the 1/2, u to the 1 minus 1/2 is u to the 1/2. And we subtract 1 over u to the 1/2, which is u to the negative 1/2. Now, all we do is raise the power by 1 and divide by the new power, and then just plug our bounds in. So u to the 3/2 over 3/2 minus u to the 1/2 over 1/2. Evaluated at 1 and 2. If I plug, this is going to be an ugly answer here. Dividing by 3/2 is the same as multiplying by 2/3. We just plug 2 in, 2 to the 3/2. We plug 1 in, or I guess I'll just finish plugging 2 in. 2 to the 1/2 over 1/2, or times 2. That's the top part plugged in. And I just did a major faux pas here. Distracted by all the Liam Romig memers. I need to figure out how to ban you, Liam. Let me fix this here. Something like this. That's 2 plugged in, and then I'm going to subtract with 1 plugged in, which is just this. And I think I did this in a couple of the classes. We wouldn't go beyond here. This is a mess. 2 to the 3/2 is just like 4 root 2 over 3 minus 2 root 2 minus 2/3 minus 2. This is good enough. The real trick is this first set of steps here, doing this U-sub so that you actually can do the division. All right. Now that we are... Okay. Dear guests in chat here, I am going to figure out how to get rid of you if you're being rude to people in this chat. These are high school students. This is an educational stream. If you can't get the heck out, then I am going to figure out how to get you the heck out. So, do not be kind. Be kind or get out. And I am just going to report Doggy because what you've done is very not okay. Yep. Cool. Wow, I'm so proud of you for having 120,000 subscribers. Your life must be complete. Alright, Maddie, chapter 4, number 1. Let's go. And then I'm probably going to head over and do a free response, which Jim I talked about, and I prepared a question, so might as well do that one. Yeah, really insecure people in chat. Feel bad for them. All right, taking the derivative of an integral. This is just our second fundamental theorem of calculus. All you do in these is plug in whatever's here into your function. Because when you take the derivative of an integral, you should get back where you started. But if you plug a variable in, you get back where you started, except with that variable plugged in. So this is just cosine of 2 pi x, which is this guy right here. Now, some caveats to this, because this one was pretty easy. But I could put a harder one, and I probably will, on our final. And here's the deal. So if I made this a little trickier, if I made this an x squared up here instead of just an x, we plug in that x squared, so we get cosine of 2 pi, and instead of u, x squared. But instead of just ending here, I actually have to multiply by the derivative of x squared, which is 2x. And this would be our answer if I had put an x squared up there. So there is a little bit of chain rule that you have to do here. And if you don't remember a lot about this, notes 21, the right side, is kind of all about this. And we did a little proof of all this on there. Okay. Yikes. The people hating in chat can't even use English well. Feels bad, man. All right. Yeah, let's do free response now. And my prepared free response. Is this one right here? And okay, so Karen's riding her bicycle on this, starting at home at 0 minutes and arriving at school at 12 minutes. During the time, her velocity is shown above, so she isn't going very fast, as far as this is concerned. Yeah. All right. Yeah, what is this bicycle speed? 0.2? Feels really bad there. Okay, I guess it is miles per minute, so maybe that is pretty quick. Yeah. Okay, so first thing is find the acceleration of the car at time equals 7.5. So if this is a velocity graph, at 7.5 is right here on this graph. And so that slope is we're going like with a -1 slope through the boxes. But since the boxes going on the y-axis are 0.1, we're actually going down 0.1 and over 1, which is just a -0.1 slope. And so it'd be negative 0.1 miles per minute squared. Acceleration is always time units squared. We're dividing by minutes with our units, and so that will be our play here. Okay, our next one. It says, using correct units, explain the meaning. I like these kinds of questions. Of the integral in terms of Karen's trip. Find the value of that integral. So the absolute value of velocity is speed. And so the integral of speed is going to give you the total distance traveled. This is different than how far you are from where you started, which is what the integral of velocity is. So if this had been the integral from 0 to 12 of velocity, that would have been that integral would give you how far you are from where you started. But the absolute value of speed gives the integral of the absolute value of velocity, which is speed, gives us the distance traveled on the interval, which you could travel towards, you could travel away, but the total distance traveled. So that's what I'd have to write here is the total distance traveled in this case in miles, because those are units, from 0 to 12 minutes. So that would be all you have to do for that part. Now, to actually find the value, what we have to do is find the area of all these geometric shapes. So the area of this triangle, the area of this triangle, which I'm going to make positive because, again, I'm finding distance traveled. So even though this is like traveling away from her house, this is traveling back towards her house because she has to like pick something up. That's kind of the deal. Calculus homework at home. And then a whole bunch more traveling here on this part. So I'm going to have to split this up into shapes that are easy to find the area of. This is probably the easiest way. It doesn't even require me to know the trapezoid area formula. Maybe I could make another cut here. 1/2 2 times 0.2 is 0.2. So this also has a area of 0.2. 5 times 0.3 divided by 2 is this area. So that's 5 times 0.15. This area is 3 times 0.1. This area here is 4 times 2, or 0.2 rather. And this area here is 1 times 0.2, so it'd be half 1 times 0.2, so 0.1. And I would add all these up to find the total distance traveled on this interval. And, you know, that's kind of a mess to add up here. So I'm going to skip that for now, but that's the play there. All right. So what I'm going to have to do is... this is really annoying. Sorry to people in my class. I gotta figure out how to get unwanted filth off this channel. So I am going to do so right now. Dun, 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 dun. Cool. And that lovely gentleman who has now been reported and blocked will no longer be able to do what he's doing. Okay. What a lovely... I miss being 7 also. Lord of Goshen. All right, Liam, if you could not invite these 10-year-olds into my chat, that would be really wonderful. All right. This is very easy now that I'm logged in as myself. And yes, the famous YouTuber, I guess, was respectful. Weird how that works. The more respectful you are, the more popular you are. Weird. All right. This is a fun cat and mouse game. I'm sorry, folks, who are here for math. All right. Sorry again, folks. I would like to continue working on this problem. I got a little distracted there. But I wanted to talk about the part C, because part C is really interesting here. Shortly after leaving home, Karen realizes she left her calculus homework at home and returns to get it. At what time does she turn around and go back home? All you have to do here is look up at this picture, which looks something like this, and see that, I talked about this earlier, but see that Karen is traveling in one direction here, and then switches and goes to another direction as she has a negative velocity. So she's going back home here. Okay. Let's get rid of this person. Chillin'. All right. So, what time does she turn around? Well, it's at t = 2 minutes that she turns around. And at 4 minutes, she leaves her house again, or I guess from 4 to 5 minutes, she's at her house, and at 5 minutes, she heads back towards wherever she's going. She's going to school, I guess. And that's how that works out. Okay, moving down to the bottom part here. Larry also rides his bicycle along a straight road from home to school in 12 minutes. I imagine being so destitute in life that you feel the need to raid a 15-viewer, 10-viewer calculus stream. Man, life is hard. All right, so Larry has this velocity equation, pi over 15 sine pi over 12 times t. That is his velocity equation. He also rides from home to school in 12 minutes. Who lives closer to school? All you have to do to figure this out is you actually figured out how far she was from school roughly in B. The only difference is you actually counted the whole distance traveled, so you'd have to subtract 0.2 twice from that number. And then you just compare that to the integral from 0 to 12 of pi over 15, sine pi over 12 t dt. And one of the cool parts about this integral is this is a U-substitution integral. My u would be pi over 12 t, and my du would be pi over 12 dt. And I have pi over 15, so I have to kind of match those up. The easiest way to do that is to actually solve for dt. dt would be du over pi over 12. And then you just plug stuff back in. And this is actually an integral that is done by hand, which is kind of crazy. Because it doesn't look like one. Sine of u, because u was pi over 12t, and dt was du over pi over 12. And pi over 15 divided by pi over 12, the pi's cancel. And I just get 12 over 15, which is 4/5 on the outside, and sine of u on the inside, and the integral is just 0 to 12. And so this is a really good example because it has a ton of stuff from our unit, and after actually doing this entire question, I'm probably going to put some ideas from this question on the actual report harassment and bullying, harassing me, report, and hide user on this channel. Easy. Probably be contacting YouTube service about this gentleman and figuring out how to get him banned from my channel forever. Yep, he probably does this in other channels too, because he has nothing better to do with his life. Feels bad, man. All right. Ladies and gentlemen, in summary, this question's really similar. I'm going to be asking you to do stuff like finding areas under curves in order to approximate values. That's what we did in all of our examples in class. I'm going to ask you maybe to explain the meaning of something in terms of questions, and that just requires looking at your units and putting things into words. I'm potentially could ask you just some sort of contextual question based on the graph and the problem. And I could also just ask you to do some sort of integral or derivative to solve some other piece of the question. And this one's like really acceleration heavy, this question. Whereas a lot of our other ones were a little more inspection or derivative based. And so this is a bit of a different take as the ones we did in class. So hopefully this was helpful. I'm sorry, I couldn't really see any like meaningful questions during that and got a little dissuaded by the 10-year-old child parading against me here. However, if anybody has any other questions or has questions about this question, I'd love if people sent that my way. Otherwise, I will probably wrap up because I can't see anything else besides people getting distracted by this gentleman who decided ruining a calculus stream was a useful use of a Sunday night. Liam, dude, I know you don't associate with him, but if you weren't dragging people to this chat, I wouldn't have had this gentleman in here. I don't advertise this anywhere except to my own students. Can we go over the last section of the quiz? Yeah, that's a great, nice capper here. Yeah. God bless. Okay. So, the last section on the quiz, and, you know, what this is kind of always going to look like, is just something like this. So I can actually just write a new one, which is probably the better of the plays here. And the question could just be, find the average value of, let's say, cosine of pi x from 0 to 10. I wonder what the answer to this is going to be. Okay, so this is a nice looking question. So I'm asking for average value. And that's what makes it off this quiz. So we've actually done at least one of these, I think question 5 on the review or something like this. And I just realized I wrote it off the page. So that was a rookie mistake. 0 to 10 of cosine of pi x dx. So we'll check this thing out. All you do in these questions, integrate. Plug in your bounds. And I realize I've made a terrible mistake. So I'm going to make my top bound 9 instead of 10. Because that's going to make it a lot more meaningful, I think. And we'd get sine of pi times 9 minus sine of pi times 1. And sine of pi times 0, rather. Sine of 0 is 0. Sine of 9 pi is the same as sine of pi, which is also 0. So I did not do a great job here. The integral would be 0, and then we'd have to divide by the width. So we'd get that the average value of cosine from 0 to 9 pi would be 0. So let's try to make this a little more meaningful so that it actually gives us an answer. Let's take a integral of, let's see, x plus sine x from 0 to 1. And I want to find the average value from 0 to 1, so again, one of these average value questions. And again, I went off the page. Classy. Okay, so if we take the antiderivative of this, we get x squared over 2 minus cosine of x. We'd plug in our bounds, 0 and 1, and we get 1/2 minus cosine of 1. And we divide by the width of the interval. In this case, the width of the interval is 1. And this is all this section is. I'm going to ask you to integrate from lower bound to high bound and divide by the width. This is not the hardest part of the test to get to Sam's question here. This is going to be easy, hopefully. It's literally the steps. Integrate, plug in, divide by width. Done. What's going to be the hardest part? I mean, the hardest part's always just what you don't know. I would really, if that question is like, what should I study for the test? I would recommend studying free response style questions. So maybe going back and taking a peek at, oops, I already have it open, these questions, and making sure you could answer all of these, or maybe even like for this question, FRQ 3 number 1 here, you could just change the graph and be like, yo, my graph is actually something like this. And then it goes up here, like triangle-like, and then it goes down to here. And then answer all the questions in this problem with this graph that I just made randomly here. And see if you can. Because it gives a meaningful average value. This one would be really boring with the relative extrema, because it never goes through 0. But you'd definitely be able to answer the S of 4, S prime of 6, S double prime of 1 questions. So it doesn't really matter what the graph is here. You could make a graph down here and answer that question. And maybe that's a good way to study for this test, because yeah, these have quite a bit of variability in them. Or just looking through, if you type in AP free response questions, into AP Calculus AB free response questions into Google, you get all of the previous ones. And if you just look for one with a graph and try to knock it out, that's probably useful practice. And being as how the skills in these questions are going to be worth at least like a third of the test, that's probably the best thing to study. Will there be optimization problems on the tests? There could be. There could be related rates, there could be optimization. I would not spend hours studying optimization because it wasn't this unit. And if it's on there, you know, maybe you study for 2 hours and get that one question right. But I would focus on second fundamental theorem of calculus, integration rules, U-Substitution integrals, stuff like that, because that's just going to get you the most bang for your buck study wise. It's going to hit the most questions you can. And yeah, are there any other questions? So the moral of the story is, don't really study optimization. You're going to get it wrong or you're going to get it right, and studying for a couple hours you might not even get the right kind. Focus on integral stuff, because that's where you're going to see a lot of benefit. Or even just some of the more generic type questions that are like on every test, like what are some good examples? Find relative maximums and minimums, absolute maxes and mins, find where your increasing interval is. Make sure you know how to do stuff like implicit, because that could show up. More general skills that are easier to prepare for are probably better use of your time than studying one of the more complicated and granular sections of the year. All right. Yeah, you said thank you a minute ago. So, yeah, sorry again, folks, for the spam. I think I did end up spamming almost all that guy's YouTube accounts. So, hopefully next time it'll be a little better. And good luck preparing for the tests and everything. And hopefully it's not too horrible. And sorry about the snow days and everything. And have a lovely Sunday night or Monday afternoon or whatever is coming your way whenever you watch this. Yeah. Good luck, y'all.